Welcome to lesson 12.3. We're multiplying rational expressions and dividing rational expressions. Think about how you multiply and divide fractions. Rational expressions are just fractions with variables in them. So let's look at our first example. We are multiplying the fraction, the rational expression, 3x plus 1 over 4 times 8x over 9x squared minus 1. So the first thing we're going to do is we are going to write this as a multiplication problem. And when we multiply fractions, we multiply our numerators and we multiply our denominators. So all I'm going to do is put both of my factors, my numerators, in the numerator as factors, and then put my denominators together as factors. And now, instead of actually multiplying or distributing here and combining like terms, what I'm going to do is I'm going to continue to factor. So I factor my denominator. My numerator was pretty much factored, and I can see here that I have common factors of 3x plus 1. So I'm going to cancel out my 3x plus 1 and 3x plus 1 in the denominator. And then also my 8 over 4 reduces to 2. So in my numerator, what is left is a 2x, and in my denominator, it's an x minus 1. Make sure your answers are in simplest form. Think about this 8x as being 2 times 2 times 2 times x, and my 4 is 2 times 2. I can cancel out two 2's in the numerator and the denominator to be just left with 2 times x, or 2x. You want to try to combine any factors that are just single terms, but any linear factors you can leave. Let's look at multiplying a rational expression by a polynomial. And again, if you were multiplying a fraction times a whole number, you would imagine that that whole number was over 1, so that you can multiply your numerators and multiply your denominators. So that's what we're going to do. We're going to pretend that our polynomial is over 1, and now we can follow what we just did in example 1, which is multiply our numerators and multiply our denominators. So I'm going to put them both in one fraction, with the 5x being one factor and the x squared plus 7x plus 12 as our second factor, and then 3x plus 12 times 1. Now that 1 really isn't necessary, and we could probably just remove that from the get-go. But at least we understand what's happening here. So now we can factor out that x squared plus 7x plus 12. And when we factor that, we're left with x plus 3 times x plus 4. And we still have the 5x plus 1. That was already factored completely. And then in our denominator, we have the 3 times the x plus 4, because we factored out a 3 here. Now, do you see any common factors? Do you see any parentheses that are exactly the same in the numerator as the denominator? And we can see here our x plus 4's are both in the numerator and the denominator. I also, at this point, would kind of cross out that 1, because factoring or multiplying by 1 does nothing for us. And then we have 5x plus 1 times x plus 3 over 3. And our answer is in simplest form. Now, some of you have asked whether you could FOIL this and get a quadratic equation in the numerator. You can. It's really an unnecessary step at this point, and I like to leave things as factors in case I need to factor something else. It just kind of all depends on what the problem, where the problem's going from here. So let's look at example 3. So in example 3, we are now dividing. Think about how you would divide fractions. You take your first fraction and multiply it by the reciprocal of the second. You flip and multiply. So what we're going to do here is we set up our division problem, and then we flip the second one, and so now we have the x squared minus 9 over x plus 8 in the in the denominator. We flipped that second fraction, so we've taken the reciprocal of the second fraction, and now we can just multiply. And so we have, here is our numerator times our numerator over our denominator times our denominator. Now what I'm going to do is I'm going to factor everything I can in my numerators. And the x squared plus 13x plus 40 is actually factored as x plus 5 times x plus 8. And my x squared minus 49 is x minus 7 times x plus 7. So now I have everything factored. I look for common factors. And again, I factor out my factors, and I reduce them, my x plus 8s and my x minus 7s. And I'm left with, in my numerator, x plus 5 times x plus 7. And that is in simplest form right now. All right, let's try one more example, and in this case, we are dividing again. And we're going to take and divide this rational expression by a polynomial. So remember, when we divide fractions, we flip the second and we multiply. So again, we're going to imagine this 8x squared plus 16x is over 1. We are going to then flip it over, and so now we have the x squared plus 9x plus 14 over 11x times 1 over 8x squared plus 16x. Then we can put it all under one fraction bar, and so we have the x squared plus 9x plus 14 in our numerator. In our denominator, we have the 11x times 8x squared plus 16x. So now I can start to factor a little bit, and I factor my numerator into x plus 2 times x plus 7. And in my denominator, I factor the 8x squared plus 16x into 8x times x plus 2. I start to look for common factors, and again, my x plus 2's will cancel out here, and I'm left with x plus 7 over 88x squared. And this is one case when if you have linear monomials and you're multiplying them, go ahead and multiply it together to get the 88x squared. Don't leave it 11x times 8x. Bring it all together. Okay? Go ahead and try the quick checks. I'm going to show you the answers in simplest form, and hopefully you're getting them right. If you have any questions about these and we don't get to them in class, or you're not in class, you can always ask. But please make sure you're staying on top of your notes and asking if you're not understanding what is going on with some of these. So in quick check example 1, we've got negative 1 over x. And again, we had to factor out that negative 1 here in order to make everything start to factor completely. In example 2, we've got 3 times the quantity c plus 1 times c plus 1. Okay, so c minus 1 times c plus 1. And that one is pretty cool how it factors. So if you ask in class if you'd like to go over that. In 3, we have to flip and multiply. So we factor out an a and the x, a minus 2 for both in the numerator and the denominator for example 3, and then we're left with 1 over b. In example 4, once we start to factor, and again we have to flip that second one and multiply, we get 1 over z plus 4. Great job. Please, if you have any questions, write them down and ask in class.